Hello, and welcome back to Math and Maticians. Today, we embark on a journey far above our planet, into the vast expanse of space, something undiscovered on this channel until now. High above us, far beyond where our air ends, floats a silent danger. This danger is not something we can see with the naked eye from the ground, but it is very real and very present. This danger threatens the technology we use every day and our future dreams of space travel. Our satellites, which provide us with communication, navigation, and even weather forecasting, are at risk. It's not aliens or a giant space rock, but a growing cloud of junk, leftovers from our own adventures in space. This debris includes defunct satellites, spent rocket stages, and fragments from disintegration, erosion, and collisions. This is the Kessler Syndrome, something a clever NASA scientist named Donald J. Kessler predicted back in 1978. He foresaw a scenario where the density of objects in low Earth orbit is high enough that collisions between objects could cause a cascade, each collision generating space debris that increases the likelihood of further collisions. It's like a chain reaction, where bits of space junk crash into each other, making more and more junk until we're trapped in a cage of our own making. This cascade effect could render space activities and the use of satellites in specific orbits difficult for many generations. In this video, we'll explore how this happens, what it could mean for us, and what we can do about it. We'll delve into the science behind the Kessler Syndrome, the potential consequences, and the innovative solutions being developed to tackle this issue. The Kessler Syndrome paints a rather gloomy picture of the future. If left unchecked, it could severely limit our ability to explore space, deploy new satellites, and even maintain the ones we currently rely on. Imagine a world without satnav, accurate weather forecasts, or even the internet. Our daily lives are intricately connected to the technology that orbits above us, and the loss of these services would be catastrophic. That's just a small taste of what could happen if we don't deal with this growing problem. The malfunctioning of satellites could lead to a breakdown in global communications, navigation systems, and even national security. It's something we need to tackle now, and it needs countries working together, clever new inventions, and a more responsible approach to space. International cooperation is crucial, as space is a shared resource and responsibility. Understanding the Kessler Syndrome isn't just something for scientists, it's about protecting our future. Educating the next generation about the importance of space sustainability is key to ensuring long-term solutions. By understanding how it works, what could happen, and what we can do about it, we can all work together to make sure space is safe for generations to come. Innovative solutions like debris removal missions and better design of satellites to minimize debris creation are steps in the right direction. The future of space travel, our technology, and even our way of life could depend on it. By taking action now, we can preserve the wonders of space for future generations and continue to benefit from the incredible technologies that space exploration has brought into our lives. Today, we're diving deep into the mechanics of the Kessler Syndrome, a phenomenon that could drastically alter our use of space. At the heart of the Kessler Syndrome is a simple but scary idea, a chain reaction of crashes. This concept, proposed by NASA scientist Donald J. Kessler in 1978, suggests that the density of objects in low Earth orbit could reach a point where collisions between objects could cause a cascade, each collision generating space debris that increases the likelihood of further collisions. Imagine two satellites bumping into each other, or a satellite hitting a piece of space junk. These aren't just minor incidents, they are catastrophic events that can lead to a significant increase in the amount of debris orbiting Earth. This doesn't just make two big things slightly smaller. Instead, it creates thousands, even millions of tiny pieces, all whizzing around space at super fast speeds. These fragments can travel at velocities up to 28,000 kilometers per hour, turning them into high-speed projectiles. These tiny pieces become like tiny bullets, making more crashes much more likely. Even a small fragment, just a few centimeters in size, can cause significant damage to operational satellites and spacecraft. Each piece could hit something else, making even more debris. This self-perpetuating cycle can lead to an exponential increase in the amount of space junk, further complicating efforts to manage and mitigate the debris problem. It's like a domino effect, a cascade of crashes that makes the amount of junk increase very quickly. The more debris there is, the higher the probability of additional collisions, creating a vicious cycle that is difficult to break. The more junk there is, the more likely things are to crash, creating a runaway effect that could make some parts of space very dangerous or even impossible to travel through. This could severely impact satellite operations, space exploration, and even our daily lives, as we rely heavily on satellite technology for communication, navigation, and weather forecasting. This cascade is made worse by two things: more and more satellites being launched into space, and old things in space breaking apart. As we continue to send more satellites into orbit for various purposes, the risk of collisions increases. These huge networks of satellites for communication and observation, called mega-constellations, add a lot of objects to already crowded orbits. Companies and governments are planning to launch thousands of satellites in the coming years, which could exacerbate the problem if not managed properly. Meanwhile, things like weapon tests in space, accidental explosions, and even old satellites falling apart add to the growing cloud of junk. These events can create thousands of new debris pieces in an instant, further complicating the situation. This mix of crashes, things breaking apart, and new launches creates a perfect storm for the Kessler Syndrome. The interplay of these factors makes it increasingly difficult to maintain a safe and sustainable space environment. Understanding how this works is vital for finding ways to stop it and making sure we can use space safely in the future. By studying the mechanics of the Kessler Syndrome, scientists and engineers can develop strategies to mitigate the risks, such as designing satellites to minimize debris creation, improving tracking and collision avoidance systems, and implementing international policies to manage space traffic. Now, what would happen if we let this get out of control? The Kessler Syndrome, if left unchecked, could spiral into a catastrophic scenario that affects not just our space endeavors, but also our daily lives on Earth. The consequences of an unchecked Kessler Syndrome reach far beyond space itself, affecting our technology, our economy, and our future dreams. Imagine a world where the very fabric of our modern society is disrupted. The ripple effects would be felt in every corner of the globe. The most immediate impact would be disruptions to the satellite services we rely on every day. These satellites are crucial for communication, navigation, and even entertainment. Without them, our world would look very different. SatNav, which we use in our cars and aeroplanes, relies on a network of satellites that are vulnerable to collisions. Imagine trying to navigate without GPS, leading to chaos in transportation and logistics. Weather forecasting, which uses satellites to track storms and predict the weather, would be severely affected, and this could put lives at risk. Accurate weather predictions are essential for preparing for natural disasters and protecting communities. Global communication networks, which allow us to do things like online banking and use the internet, could experience widespread outages. The internet, which has become the backbone of our modern world, would be severely compromised. The economic impact of these disruptions would be huge, affecting businesses that depend on these essential satellite services. Financial markets, which rely on precise timing and data, could face unprecedented challenges. Beyond the immediate economic and technological impacts, the Kessler Syndrome also threatens our future in space. Our ambitions to explore and colonize other planets would be hindered by the dangerous debris fields. Missions to the Moon, Mars, and beyond would be much more dangerous because of the hazardous orbital paths. The dream of becoming a multiplanetary species could be delayed or even derailed. Launching and maintaining satellites would become incredibly expensive because of the need to avoid collisions and deal with the debris. The cost of space missions would skyrocket, making it difficult for both governments and private companies to justify the expense. We also can't ignore the environmental impact. The accumulation of space debris poses a long-term threat to the sustainability of our orbital environment. While some debris might fall back to Earth and burn up, larger pieces could pose a serious threat if they landed in populated areas. The risk of debris causing damage or injury on the ground is a real concern. The buildup of junk in orbit could also stop future generations from exploring and using space, leaving them with a mess we created. It's our responsibility to ensure that space remains a viable frontier for future explorers and innovators. So, what are we to do about it? At the moment, there are a few things being done to tackle the growing problem of space junk. These include better systems for tracking the junk, designing satellites that are less likely to create debris, and technology to actively remove debris from space. These are helpful, but they're not enough to completely solve the problem. Looking to the future, new technologies and long-term plans offer hope for a more sustainable future in space. Clever ideas like repairing satellites in space, advanced engines and satellites that can automatically avoid collisions are being developed. These advancements could greatly reduce the risk of crashes and help us manage the junk that's already up there. Working together is key to making space sustainable. Countries and organizations around the world need to cooperate to create rules and best practices for space activities. By sharing information and resources, we can make space safer and more sustainable for everyone in the future. Dealing with the Kessler Syndrome is incredibly important. If we ignore it, the chain reaction of collisions could make certain orbits unusable for decades or even centuries. By taking action now, we can ensure that space remains a valuable resource for all humankind. Thanks again for tuning in. Until next time, stay calculating, my friends.